powerful tool called as the Lami's theorem. This is used in mathematics, but we will be using this property of the Lami's theorem or the Lami theory's application in physics. What does it say? That if there are three concurrent forces, means the forces passing through same line, if there are three concurrent forces F1, F2 and F3, and the angle between them are alpha, beta and gamma, then F1 upon sine alpha is F2 upon sine beta is F3 upon sine gamma. It goes like this. You can draw three concurrent forces. Concurrent means passing through the same point. This is F1, just assume that the angle opposite this is alpha. This is F2, angle opposite this is beta. This is F3, that angle opposite this is gamma. And this is the case. F1 upon sine alpha, F1 upon sine alpha is F2 upon just angle opposite that sine beta, and F3 upon sine. One more condition is there, if there are three concurrent forces F1, F2, F3 or F1 plus F2 plus F3 equal to 0. So the vector quantity means when the vectors forming the closed loop. So like if this is F1, this is F2 and this is F3, and they are forming the closed loop, then also this theorem holds true, because this is the condition. ABC is the, we don't have to find the derivation of that, we will be using the property of this, because we have to find the resultant of the vector quantities. So we need to find some mathematical tool, and this is the tool which is going to help us. One more powerful tool is there, and that is called the vector addition of the two components, like the resultant vectors, two vectors. And then how to find the resultant of the vectors, you might have studied the parallelogram laws also, this is called. So after cleaning this screen, I am going to discuss about the parallelogram law, and then with the help of some example I will apply these two ideas to find the resultant force. So this is also another handy tool that will be used in the physics to find the resultant of the two forces on the different charges acting on them. So we will be using the parallelogram law of the vectors, and this is something like this. Suppose that you have two forces. This is force 1, F1, and this is another force. This is F2, and the angle between them is theta. Then what will be the resultant? The parallelogram law says that just you draw a parallelogram. This is your F2 and this is your F1, because opposite sides of the parallelogram are equal and they are parallel, so this F2 will parallel to this. Now I have to drop one perpendicular. Suppose I give it a name like A, B, C, D, and I have, the resultant will be something like this in between these two. It can be here around the diagonals. Experimentally it has been proved. So I just drop one perpendicular from here, and this is 90 degrees. So these two angles are corresponding angles, so this is also theta. Now if you use trigonometry, you will find this side is F2 sine theta, and this part is F2 cos theta. This I call it as CM. So now you see that our triangle ACM is a right angle triangle. So the triangle ACM. So in triangle ACM, we can apply the Pythagoras theorem easily, and that is AC square is CM square plus AM square. Now CM, AC square, if I call the resultant as the force F, because the resultant of the two force can be a force. This rule can be used to find the resultant of the displacements, of the velocities, of acceleration for any vector quantities, mind you. So F square is CM square. What is CM? That is F2 sine theta, F2 sine theta whole square plus AM, that is AB plus BM, and it's F1 plus F2 cos theta. So F1 plus F2 cos theta. So if you find the square of this, now you can see. Do you see it properly? Then this equation. So it becomes F square equals, so that is F2 square plus F2 square. So what it becomes? F2 square sine square theta plus this is A plus B whole square, that is F2 square cos square theta plus F1 square plus 2F1 F2 cos theta. Is it seen now this also properly? Everybody is clear? Okay. So now here you see that this F square is, so you see F2 square and F2 square cos square theta and F2 square sin square theta. If you take F2 square common, this will become F2 square in bracket sin square theta plus cos square theta, that is 1. So better I write F1 square, this one first, and the second one F2 square. This is the resultant of these two. If you add them, you'll only get F2 square, because sin square theta plus cos square theta is true, and this is the identity, it's true for all values. So F2 square, and this is 2F1 F2 cos theta. So now I have to find F. So what is F? F is under root of F1 square plus F2 square plus 2F1 F2 cos theta. So this is the resultant. Now this is the direction, because since it is a vector quantity, we are more interested in finding out the what angle is the resultant making one of the known vectors, that is F1 or F2. So it means alpha. Alpha is the angle between the F1 vector that is known. So if a vector quantity is known, definitely sense of direction and the magnitude both are known, and F2's magnitude we have already found. So we need to find out what is the angle between them, so that we can locate this resultant vector. So again we use trigonometry and find tan alpha is opposite upon adjacent, that is F2 sine theta upon F1 plus F2 cos theta. So alpha is the angle, and that you can find as tan inverse F2 sine theta over F1 plus F2 cos theta. And if you are interested in finding out the angle between the F2 vector along with this F2 vector and this resultant, then this is this angle, and that is definitely theta minus alpha. Since theta is already known and alpha here you have found out, so that is theta minus alpha. This is going to be a very handy tool for you to use in the numericals of solving questions based on the Coulomb's law, which I am going to discuss, but for that I need to clear my screen. 5 meters, because I don't want to go into the Celsius or other units. So what happens that we have to find the force experienced by this particle due to this. So you know that this angle is 60 degree, and this is also 60, this is also 60. So you have one force acting here in this direction, and that is the resultant force on this due to this. So I name it as A, B, C, and this is another one goes like this. That is the force on this due to this. So now if you see that the force, suppose I give the name as force on A due to, so force on A due to B is equal to 1 by, I just want to write K only instead of using 1 by 4 pi epsilon naught 10 to the power. Is it clear now? So K into, now the 1 into 1, so K square will be 1 square over the distance is 5 square, that is 25. So this is K over 25. Now this force is also going to be F on A due to C, that is K, again magnitude are same, so it is 1 upon 25, that is K upon 25. And now you see this is 60, so this is also 60, this is vertically opposite angles. So it means that I'll use my parallelogram law that I have two forces, one here and the one here. The angle between them is 60 degree. This is K over 25, that is also K over 25. So I don't need to draw, but since for understanding I am doing this, so I use this F. So what is F? F is under root of this square plus this square. So this is K square over 625 plus K square over 625 plus 2K square. So 2K square over 625 cos 60, that is half. So this half and this half cancel, so you are getting under root 3K square over 625, and that is under root 3 times K over 25. And if you know the value of K, that is root 3 upon 25, and that is 9 into 10 to the power 9. So I take just 100 out of this, this will become 10 to the power 7. 900 upon 25 is 36, so this is 36 root 3 into 10 to the power 7 Newton. Now what will be the angle, because this value is K upon 25 sine 60, that is root 3 upon 2, and this is K upon 25 cos 60, that is half. So the angle alpha will be tan alpha. Tan alpha is opposite, that is root 3k upon 50 upon sum of these two, that is K upon 25 plus half, just like 1 and half is 3 by 2 K upon 25. So you see that the K and the K will cancel each other, and then what I'll get 3K over 50 and reciprocal of 50 over 3K, that was root 3K. So 3K, this 50 cancels, getting 1 by root 3. Now tan alpha is 1 upon root 3. So alpha is tan inverse 1 upon root 3, and that is pi by 6, means 30 degrees. So it means the resultant force will be making angle 30 degree with the positive direction, so it goes something like this. So the force is acting. So this is how you use the idea of the vectors to solve the questions based on the Coulomb's law. Thank you very much. The next video will discuss about the electrostatic field or the electric field. Thank you.